In this question, we're told that there are only blue cubes, red cubes, and yellow cubes in a box. The table below shows the probability of taking at random a blue cube from the box. The number of red cubes in the box is the same as the number of yellow cubes in the box. And in part A, we need to complete the table with the unknown probabilities. Now we know that the sum of probabilities is equal to 1. Now since we're told that the number of red cubes in the box is the same as the number of yellow cubes in the box, we can say that the probability of taking a red cube is equal to the probability of taking a yellow cube. So let's start by doing 1 take away 0.2, which is equal to 0.8. And so we can say that 0.8 is the total probability of taking red or taking yellow. Well, now since the probability of taking red is equal to the probability of taking yellow, we can do 0.8 divided by 2, which is equal to 0.4. And so this means that the probability of taking red is equal to 0.4, and the probability of taking yellow is also equal to 0.4, since these probabilities are equal and add up to 0.8. We're now told that there are 12 blue cubes in the box, and in part B, we need to work out the total number of cubes in the box. Well, from our table, we know that the probability of taking a blue cube is equal to 0.2, and so we can say that 0.2 is equal to 12. Now in part B, it might be easier to work with percentages. 0.2 is equal to 20%, and so we can say that 20% of the total number of cubes in the box is equal to 12. Now before we continue with this question, we need to establish that the total number of cubes would be the value equal to 100%. Now since we know 20%, we need to work out 100%. Now to get from 20% to 100%, we want to multiply both sides by 5. 12 multiplied by 5 is equal to 60, and so we can now say that the total number of cubes is equal to 60, which we can write down in our answer box below. Now this question is worth 4 marks. In part A, we get 1 mark for doing 1 take away 0.2 is equal to 0.8, and we get the second mark in part A for dividing this value by 2 and for finding that the probability of taking a red is equal to 0.4 and the probability of taking a yellow is also equal to 0.4. Now in part B, we get 1 mark for establishing that 20% is equal to 12, and to get to 100%, we need to multiply by 5. And we get the second mark for correctly multiplying 12 by 5 and for finding that the total number of cubes in the box is equal to 60. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and 2 times as much butter as sugar. We're told that Dion is going to make 60 biscuits, and in part A, we need to work out the amount of flour she needs. We can start by working out the amount of sugar, flour, and butter that Dion needs to make 15 biscuits. We're told that she needs 50 grams of sugar. If she needs 3 times as much flour as sugar, the amount of flour she needs is 50 multiplied by 3, which is equal to 150 grams. We're told that she needs 2 times as much butter as sugar, and so the amount of butter she needs is 50 multiplied by 2, which is equal to 100 grams. But we're told that Dion is going to make 60 biscuits, and we need to work out the amount of flour she needs for 60 biscuits. We need to figure out what we need to multiply to go from 15 to 60. And so to get from 15 to 60, we multiply by 4. Now we only need to know how much flour she needs, so we don't need to multiply every single quantity, we just need to multiply the quantity for flour. And so the amount of flour that Dion will need for 60 biscuits would be 150 multiplied by 4, which is equal to 600 grams. And so we've now found that the amount of flour that Dion needs to make 60 biscuits is equal to 600 grams. Now in part B, we're told that Dion has to buy all of the butter she needs to make 60 biscuits, and she buys the butter in 250 gram packs. we need to find out how many packs of butter that Dion needs to buy. Well, first we need to find out how much butter she needs for 60 biscuits. And we can go back to our diagram in Part A to help us do that. We know that we need 100 grams of butter to make 15 biscuits. And so to make 60 biscuits, we'll need 100 multiplied by 4, which is equal to 400 grams of butter. So we now know that to make 60 biscuits, we need 400 grams of butter. Now if the butter comes in 250 gram packs, we need to find out how many packs of butter that Dion needs to buy. So to do this, we'll do 400, which is our total amount of butter, divided by 250, which is equal to 1.6. But this is where we need to be careful. Our final answer is not equal to 1.6 because we can't buy a decimal number of packs of butter. Well, this means that we need to round up. If we need 1.6 packs of butter, we need to buy 2 packs so that we have enough butter to make 60 biscuits. Now our answer is 1.6, and we said that we need 2 packs of butter so that we have enough to make 60 biscuits. And so we can write this down in our answer box below. Now this question is worth 5 marks. In Part A, we get 1 mark for realising that the multiplier is 4, and so to get from 15 biscuits to 60 biscuits, we multiply by 4. We get the 2nd mark for attempting to do 150 multiplied by 4, which we can see over here. And we get the 3rd mark for getting our correct final answer that the amount of flour she needs to make 60 biscuits is equal to 600 grams. Now in Part B, we get 1 mark for starting the process to do 400 divided by 250. And we get the 2nd mark in Part B for realising that our answer of 1.6 means that she needs to buy 2 packs of butter. And so we get the 2nd mark for getting our final answer of 2. And so we've now achieved the full 5 marks needed in this question. In this question, we need to find the highest common factor of 72 and 90. And to do this, we can start by drawing prime factor trees for both numbers. We'll start with 72. So we need 2 numbers which multiply to give 72. And so we can use 8 and 9. We can break 8 and 9 down further. 8 is equal to 4 multiplied by 2. And 9 is equal to 3 multiplied by 3. Now remember, in prime factor trees, we have to circle the prime numbers. And so we can circle 2, we can circle 3, and we can circle the other 3. But 4 can still be broken down further. And 4 is equal to 2 multiplied by 2. We can also circle both of these 2's because they're prime numbers that can't be broken down any further. So we can write 72 as a product of its prime factors. And so we can say that 72 is equal to 2 times 2 times 2 times 3 times 3, because we listed all of the prime numbers on our factor tree. Now we can do the same for 90. We need 2 numbers which multiply to give 90, and so we can start with 9 and 10. Now we can't circle anything yet, because neither 9 nor 10 are prime, and they can be broken down further. 9 can be broken down into 3 multiplied by 3, and 10 can be broken down into 5 multiplied by 2. Now all of these numbers are prime, so we can circle them. And so we can say that 90 as a product of its prime factors is equal to 2 multiplied by 3 multiplied by 3 multiplied by 5. Now to find the highest common factor, we can use a Venn diagram. And in this Venn diagram, we're going to put the prime factors of 72 and 90, and their common prime factors will go in the intersection. Now a prime factor of 72 is 2, and there's also a prime factor of 2 in 90. So if this is a common factor, we can put this in the intersection on our Venn diagram. Now another prime factor of 72 is 3, which also exists in 90. This is another shared factor, so we can put this in the intersection. And they also share another 3, which we can put in our intersection. Now the prime factors left on our factor tree for 72 is 2 and 2. Now since 90 doesn't have any more prime factors of 2, the remaining prime factors of 72 are not shared, and so these just go in the section for 72. And in 90 we have 5 remaining, Well, 72 doesn't have a prime factor of 5, so this isn't a shared factor, and so 5 goes in the section for 90. Now to find the highest common factor, we want to multiply the values in the intersection, and so the highest common factor of 72 and 90 would be equal to 2 multiplied by 3 multiplied by 3, which is equal to 18, which we can write down in our answer box. Now this question is worth 2 marks. We get 1 mark for listing the prime factors of 72 and 90. We use the prime factor tree in order to help us do that. And our second mark in this question is for finding that the highest common factor is equal to 2 times 3 times 3, which gives us an answer of 18, allowing us to achieve the full 2 marks needed in this question. In this question, we're given a plan, front elevation and side elevation of a solid shape, drawn on a centimetre grid. In the space below, we need to draw a sketch of the solid shape, given the dimensions of the solid on our sketch. Now let's take a look at the plan, front and side elevation. We have a plan of a circle, which means that when we look at the shape directly above it, we'll see the shape of a circle. Now the front elevation, when opened up, would show a rectangle, and the side elevation would show the exact same rectangle. And so from this, we can identify that the solid shape we need to sketch is a cylinder. And so we can start to draw a sketch below. Well, now that we've drawn a cylinder, we need to work on finding the dimensions. This grid is a centimetre grid, so each square is equal to 1 centimetre. Now looking at our plan, we can see that the radius of this circle is equal to 2 centimetres. We can also see that the height of the rectangle is equal to 5 centimetres, and that the width of this rectangle is equal to 4 centimetres. And so we can put these dimensions on our diagram below. We know that the radius of the circle is 2 centimetres. Now the height of our front elevation and side elevation would be the same as the height of our rectangle, and so we can say that our rectangle is 5 centimetres long. Now the last dimension that we need to add in is the 4 centimetre dimension. Now if the width of our rectangle for our front and side elevation is equal to 4 centimetres, we can say that the width of our cylinder is equal to 4 centimetres. Now the width would be this length here. Now this length here goes from one end of the circle to the other end of the circle, passing through the centre. And so we can say that this length is the diameter. So we've now seen that the diameter of the circle is equal to 4 centimetres, which makes sense because we know that the radius is 2 centimetres and the diameter would be twice the length of the radius. And so using the plan, front elevation and side elevation of a solid shape, we've now drawn this solid shape with the correct dimensions on our sketch. Now this question is worth 2 marks. We get 1 mark for identifying that this shape is a cylinder and for sketching a cylinder correctly. And we get the 2nd mark for drawing the correct dimensions on our sketch, and for finding that the height of our cylinder is equal to 5 centimetres, the radius is equal to 2 centimetres, and the diameter is equal to 4 centimetres. And so we've now achieved the full 2 marks needed in this question. In this question, we're told that shape A can be transformed to shape B by a reflection in the x-axis, followed by a translation by the vector CD. We need to find the value of C and the value of D. Well, we're told that this transformation starts with a reflection in the x-axis, so we can start by sketching this on our diagram. Now looking at triangle A, we'll label the 3 points X, Y and Z. So now we can reflect each point in the x-axis individually. We'll start with point X. To get to the x-axis, we need to go 2 spaces down. And so we can do the same thing on the other side of the x-axis, and the new point X will be over here. Now for Y, to get to the x-axis, we need to go 1, 2, 3, 4, 5 squares down. And so we can go 5 squares on the other side of the x-axis, and so the new point Y will be over here. And finally for point Z, we want to go 2 spaces down, and so we can do 2 spaces on the other side of the x-axis, and Z will be over here. Now we can remove our construction lines and join the 3 new points together. Now that we've reflected shape A in the x-axis, we need to find the translation to get from this reflected shape to shape B. And to do this, we can map each individual point onto its corresponding point on shape B. Now looking at shape B, we can identify this point to be x, this to be z, and this to be y. And so to get from x on the reflected shape to x on shape B, we can trace its path. We start by going 6 spaces to the left, and then 1 space down. Now we only really need to do this for one point, and we did it for point x, but it's always good to try it with other points to make sure we've got it correct. Now we don't need to do all of the points, but let's confirm by doing one more, so let's do point y. To get from point y on the reflected shape to point y on shape B, we need to move 6 spaces to the left, and then we need to move 1 space down. Since point x and point y both follow the same path, 6 spaces left and 1 space down, we can see that we have the path correct. Now we need to write this in the form of a vector. Well, in this vector, C represents the x-axis translation, and D represents the y-axis translation. On the x-axis, we're moving 6 spaces to the left, and on the y-axis, we're moving 1 space down. Now in vector form, 6 spaces to the left is equal to -6, and 1 space down is equal to -1. And so we've found that the vector CD is equal to -6, -1, which we've written down in the space provided. Now this question is worth 3 marks. We get the first mark for reflecting shape A in the x-axis, and having this drawn on our diagram. We get the second mark for correctly finding that C is equal to -6, and for finding that D is equal to -1, allowing us to achieve the full 3 marks needed in this question. In this question, we're told that a shop sells packs of black pens, packs of red pens, and packs of green pens. We're told that there are 2 pens in each pack of black pens, 5 pens in each pack of red pens, and 6 pens in each pack of green pens. And on Monday, the ratio of the number of packs of black pens sold to the number of packs of red pens sold to the number of packs of green pens sold was equal to 7 to 3 to 4. Now we're told that a total of 212 pens were sold, and we need to work out the number of green pens that were sold. Well, the first thing that we can do is to start by finding the ratio of the number of pens that were sold. Now we're given the ratio of the number of packs of each colour sold, but we're told the number of pens in each pack. And so we can use this in order to find the ratio of the number of pens of each colour sold. So let's look at the number of packs of black pens that were sold. In the ratio, this is equal to 7 parts. We're told that there are 2 pens in each pack of black pens, and so this can change to 2 multiplied by 7. And then we have the number of packs of red pens, which in our ratio is equal to 3 parts. We know that there are 5 pens in each pack of red pens, and so for the number of red pens sold, we'd do 5 multiplied by 3. And finally, the number of packs of green pens sold has 4 parts. There are 6 pens in each pack of green pens, and so to find the ratio for the number of green pens sold, we'd do 6 multiplied by 4. So we can see that our new ratio would be equal to 2 times 7, to 5 times 3, to 6 times 4, which would give us a ratio of the number of pens of each colour sold, rather than the number of packs. Now we can simplify this ratio, which is equal to 14 to 15 to 24. Now what we can also say is that 14 plus 15 plus 24 is equal to 53, and so we can see that there are 53 parts in total. Well, now we can use this ratio of the number of pens of each colour sold in order to find the number of green pens that were sold. We're told that a total of 212 pens were sold, and so the number of green pens sold was a fraction of this amount. We need to find the proportion of green pens that were sold. Now looking at our ratio, green has 24 parts, and this is out of a total of 53 parts, and so the proportion of the number of green pens sold is 24 divided by 53. Now this proportion is out of the total number of pens sold, and so to find the number of green pens sold, we'd do 24 out of 53 multiplied by the total of 212 in order to give us an answer of 96. and so we've now found that the number of green pens sold is equal to 96. Now this question is worth 4 marks. We get the first mark for finding the ratio of the number of pens of each colour sold, and for getting a ratio of 14 to 15 to 24. We get the second mark for finding the proportion of green pens sold, which is equal to 24 over 53. We get the third mark for a process to find the number of green pens sold by doing this proportion multiplied by the total of 212. And the fourth and final mark is for getting the correct final answer that the number of green pens sold is equal to 96, allowing us to achieve the full 4 marks needed in this question. In this question, we're given 2 rectangles. We have rectangle ABCD and PQRS. We're told that length QR is equal to 10 cm, and that the length BC is equal to length PQ. The perimeter of ABCD is equal to 26 cm, and the area of PQRS is equal to 45 cm squared. We need to work out the length of AB. Let's start by labelling our diagram with what we know. We're told that QR is equal to 10 cm. We're told that BC is equal to PQ, and so we can call this side X. We'll say PQ is equal to X centimetres, and so that means BC is also equal to X centimetres. Now since these are rectangles, opposite sides are equal, and so we can say that length SR is also equal to X centimetres, and length AD is also equal to X centimetres. Now we're also told that the perimeter of ABCD is equal to 26 centimetres, and that the area of PQRS is 45 centimetres squared. Now since we don't know the length of AB, and therefore DC, we can call this another unknown. And so we can say that length AB is equal to Y centimetres, which means that length DC is also equal to Y centimetres. Now let's use what we know about the area and the perimeter of rectangles. So let's look at shape ABCD. Now the perimeter would be equal to all of the side lengths added together. And so we can say that X plus Y will give us the perimeter, which we can simplify into 2X plus 2Y. We know that the perimeter is 26 centimetres, and so we now have an expression that 2x plus 2y is equal to 26. Now let's look at rectangle PQRS. Now to find the area of this rectangle, we will do the base multiplied by the height. We have a base of x and a height of 10, and so we can say that the area is equal to x multiplied by 10, which we know is equal to 45. And so we now have an expression that 10x is equal to 45. Now this expression is going to be really useful, because we only have one unknown. We can use this to find x. If 10x is equal to 45, we can find x by dividing both sides by 10. 45 divided by 10 is equal to 4.5, and so we've found that x is equal to 4.5 centimetres. Now in this question, we're asked to find length AB, which we said was equal to y. So let's go back to our expression that 2x plus 2y is equal to 26. We've now found that x is equal to 4.5, so we can substitute this value into our expression. 2x plus 2y would be equal to 2 multiplied by 4.5 plus 2y is equal to 26. We can simplify this into 9 plus 2y equals 26. Now subtracting 9 from both sides, we'll have 2y is equal to 17. And so y is equal to 17 divided by 2, which is equal to 8.5. Now since y is equal to 8.5, and we said that length AB is equal to y, we've found that the length AB is equal to 8.5 centimetres. Now this question is worth 4 marks. We get the first mark for creating the two expressions for the perimeter and the area, and we found that 2x plus 2y is equal to 26, and 10x is equal to 45. We get the second mark for a process to find the value of x, by using the fact that 10x is equal to 45, and so x would be equal to 4.5. Now our third mark is for using our found value of x and for substituting this in to the expression 2x plus 2y is equal to 26, and for finding that 2 multiplied by 4.5 plus 2y is equal to 26. And our fourth and final mark is for rearranging to find y, and for finding that y is equal to 8.5, and for therefore concluding that the length of AB is equal to 8.5 centimeters, allowing us to achieve the full 4 marks needed in this question. In part A, we need to work out an estimate for the value of the square root of 63.5 multiplied by 101.7. Now when we're asked to work out an estimate, it's always a good idea to round to two significant figures. So we can round both of our numbers to two significant figures. 63.5 to two significant figures is equal to 64, and 101.7 rounded to two significant figures is equal to 100. And so we can rewrite this as the square root of 64 multiplied by 100. We know that the square root of 64 multiplied by 100 is equal to the square root of 64 multiplied by the square root of 100. Now 64 and 100 are both square numbers. The square root of 64 is equal to 8, and the square root of 100 is equal to 10. And so we can simplify this into 8 multiplied by 10. And this will leave us with an answer of 80. And so we can say that an estimate for the value of the square root of 63.5 multiplied by 101.7 is equal to 80. Now in part B, we're told that 2.3 to the power of 6 is equal to 148, correct to three significant figures. And we need to find the value of 0.23 to the power of 6, correct to three significant figures. Now 0.23 can be written as 2.3 divided by 10. And so we can say that 0.23 all to the power of 6 is the same as saying 2.3 divided by 10 all to the power of 6. Now using our index laws, we can say that 2.3 divided by 10 all to the power of 6 is equal to 2.3 to the power of 6 divided by 10 to the power of 6. Now in the question, we're told that 2.3 to the power of 6 is equal to 148. And so we can simplify 2.3 to the power of 6 divided by 10 to the power of 6 into 148 divided by 10 to the power of 6. Now we need to do 148 divided by 1 million, which will leave us with an answer of 0.000148. Now finally, in part C, we need to find the value of 5 to the power of minus 2. We know that when we have a negative power, we need to find the reciprocal. And so 5 to the power of minus 2 is equal to 1 over 5 to the power of 2, which we can now simplify further, because 5 to the power of 2 is equal to 25, 1 over 5 to the power of 2 would be equal to 1 over 25. And so our answer to part C is 1 over 25. Now this question is worth 4 marks. In part A, we get the first mark for rounding to two significant figures and for saying that the square root of 63.5 multiplied by 101.7 is approximately equal to the square root of 64 multiplied by 100. And the second mark in part A is for simplifying to get an estimate of 80. Now in part B, we get the 1 mark for getting the correct answer of 0.000148. And in part C, we get the 1 mark for getting the correct answer of 1 over 25. And so we've now achieved the full 4 marks needed in this question. In this question, we need to work out 3½ multiplied by 1 3/5, giving our answer as a mixed number in its simplest form. Now let's start by converting 3½ and 1 3/5 into mixed numbers. We'll start with 3½ We can say that 3 is equal to 6 over 2, and so 3½ would be equal to 6 over 2 plus 1 over 2, which is equal to 7 over 2. Now let's move on to 1 3/5. We can say that 1 is equal to 5 over 5. And so 1 3/5 would be equal to 5 over 5 plus 3 over 5, which is equal to 8 over 5. And so we can say that 3½ multiplied by 1 3/5 is equivalent to 7 over 2 multiplied by 8 over 5. We know that when we multiply fractions together, we multiply the numerator and then we multiply the denominators. and so 7 times 8 is equal to 56. And 2 multiplied by 5 is equal to 10. And so we now have an answer of 56 over 10. We need to give our answer as a mixed number in its simplest form. Now we need to think of the highest multiple of 10 that can go into 56, and so this number would be equal to 50. So 56 over 10 is equal to 50 over 10 plus 6 over 10. 50 over 10 can be simplified into 5, and so we're left with 5 plus 6 over 10. But this isn't quite our final answer, because 6 out of 10 is not in its simplest form. Now to simplify 6 over 10, we can divide both the numerator and the denominator by 2, and so 6 over 10 is equal to 3 over 5 in its simplest form. Now going back to our answer, we said that 56 over 10 is equal to 5 plus 6 over 10, which is equal to 5 plus 3 over 5. And so we've now found that our answer as a mixed number in its simplest form is equal to 5 3/5. Now this question is worth 3 marks. We get the first mark for converting our fractions in the question into mixed numbers, and for finding that 3½ is equivalent to 7 over 2, and 1 3/5 is equivalent to 8 over 5. We get the second mark for multiplying these values together, and for finding that 7 over 2 multiplied by 8 over 5 will give us an answer of 56 over 10. And we get the third and final mark for correctly simplifying 56 over 10 into a mixed number in its simplest form, and we said that 56 over 10 is equivalent to 5 3/5, allowing us to get the full 3 marks needed in this question. In this question, we're told that the graphs with equations 3y plus 2x is equal to 1 over 2, and 2y minus 3x is equal to minus 113 over 12 have been drawn on the grid below. Now using the graphs, we need to find estimates of the solutions of the simultaneous equations given below. Now these two equations have been drawn on our graph, and so we can use the graph in order to find the solutions. Now the solution of these two lines would be the point at which they intersect, which we can label on our graph. And so to find the estimates of the solutions of the simultaneous equations, we need to find the coordinates of this point of intersection. Well, now that we've zoomed into our graph, we can find the coordinates of this point of intersection. Let's start with the x-coordinate by drawing a line from the point until the x-axis. Now looking at our blue line, the point at which this meets the x-axis is at roughly x is equal to 2.25. And now let's do the same thing for the y-axis. And so we can see that the y-coordinates of our point of intersection is at roughly the point when y is equal to minus 1.35. Well, now that we've found our coordinates for the point of intersection, we can write this down in our answer box. So we found that the x-coordinates of our point of intersection is equal to 2.25, and the y-coordinates of our point of intersection is equal to minus 1.35. Now this question is worth 2 marks. We get the first mark for recognising that the solutions of these simultaneous equations would be found at the point of intersection. And we get the second mark for finding the correct x and y coordinates of this point. And so the mark scheme allowed a range of answers. Now the value for x had to be in between 2.2 to 2.3. We have an answer of 2.25, which falls within this range, and so this is correct. And then the values for y were allowed to be given in the range minus 1.3 to minus 1.4. Our answer of minus 1.35 falls within this range, and so we can say that this is correct. Now since we found the correct solutions for the x and y coordinates of the point of intersection, we can now get the second mark. And so we've now achieved the full 2 marks needed in this question. In this question, we're told that a bus company recorded the ages in years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. And in part A, we need to complete the table below to show information about the ages of people on coach A. We're looking at our table. We need to find the median, the lower quartile, and the upper quartile. We know that there are 23 people on coach A in total, and so we can say that n is equal to 23. Now before we begin to find the median, the lower quartile and the upper quartile, we need to make sure that our data is in order. Now looking at our data, we can see that the values are in ascending order, and so we can continue with our question. Now to find the median, we want to find the middle value, and to do this, we'll find the value that is at the position n plus 1 over 2. N is equal to 23, so 23 plus 1, all divided by 2, is equal to 24 divided by 2 is equal to 12, and so the median will be found at the 12th position. So now let's take a look at our data. So the 12th item in our set of data is over here, and so we can see that the median is equal to 59. Now we need to find the lower quartile, and to find the lower quartile, we need to find the piece of data at the n plus 1 over 4 position. N plus 1 over 4 is equal to 23 plus 1 over 4, which is equal to 24 divided by 4, which is equal to 6, and so the lower quartile is found at the 6th position. Now looking at our data, we can see that the 6th item of our data is equal to 53, and so we've found that the lower quartile is equal to 53. Now we need to move on to the upper quartile. Now the upper quartile is found 3/4 of the way along the data, which we can find by doing 3 multiplied by n plus 1 over 4. So n plus 1 is equal to 24. This multiplied by 3 is equal to 72. And then this all over 4 is equal to 18. And so the upper quartile is found at the 18th position. Now taking a look at our data again, we can see that the 18th position is over here. The item of data at the 18th position is equal to 66. And so we've found that the upper quartile is 66. Well, now let's move on to part B. We're also given some information about the ages of the people on coach B. Richard says that the people on coach A are younger than the people on coach B, and in part B, we need to say whether or not Richard is correct, giving a reason for our answer. Now in a question like this, we need to compare the median result. Now looking at coach A, we can see that the median age is 59, and looking at coach B, we can see that the median age is 70. Well, 59 is less than 70, which means that the median value on coach A is younger than the median value on coach B. Richard says that the people on coach A are younger than the people on coach B. Well, since 59 is less than 70, we can say that Richard is correct. Now finally, Richard says that the people on coach A vary more in age than the people on coach B. And in part C, we need to find out whether or not Richard is correct, giving a reason for our answer. Now the key word here is vary, and when we're asked about the variance of data, we want to look at the range. And so the range of values on our data would be equal to the largest value, take away the smallest value. We need to find the range of values for coach A, and the range of values for coach B. The largest value on coach A is 79, and the smallest value is 41, and so the range of coach A is 79 take away 41, which is equal to 38. Now for coach B, the largest value is 85, and the smallest value is 42, and so the range is 85 take away 42, which is equal to 43. Now we can see that the range of coach A is less than the range of coach B, which means that the ages of the people in coach A are less varied than the ages of people on coach B, because a smaller range means there's less variation. And so we can say that Richard is incorrect, because 38 is less than 43, and so the people on coach A do not vary more in age than the people on coach B. Now this question is worth 4 marks. We get the 2 marks in part A for getting the correct values for the median, lower quartile, and upper quartile. In part B, we get the 1 mark for stating that Richard is correct and for giving a valid reason, and our reason was that the median for coach A is less than the median for coach B. And in part C, we get the 1 mark for saying that Richard is not correct and for giving a valid reason, and this is because the range of A is less than the range of B. And so we've now achieved the full 4 marks needed in this question. In this question, we're given 3 spheres. We're told that the volume of Q is 50% more than the volume of sphere P. and the volume of sphere R is 50% more than the volume of sphere Q. We need to find the volume of sphere P as a fraction of the volume of sphere R. Well, let's start by saying that the volume of P is equal to V. We're told that the volume of sphere Q is 50% more than the volume of sphere P. Now when we have a 50% increase, we multiply by 1.5. We can say that the volume of sphere Q is 1.5 multiplied by V, which is equal to 1.5V. Now we're told that the volume of sphere R is 50% more than the volume of sphere Q. And again, we can apply the same principle. To have a 50% increase, we multiply by 1.5. Now if sphere R is 50% more than the volume of sphere Q, the volume of sphere R would be equal to 1.5 multiplied by 1.5V, which we can simplify and say is equal to 2.25V. Now we're asked to find the volume of sphere P as a fraction of the volume of sphere R. We know that the volume of sphere P is equal to V, and the volume of sphere R is equal to 2.25V. And so to find the volume of sphere P as a fraction of the volume of sphere R, we can say that the fraction is equal to V over 2.25V. Now we need to simplify this. We can see that the V's are going to cancel out. And so by dividing both the numerator and the denominator by V, we're left with 1 over 2.25. We can multiply both the numerator and the denominator by 100 so that we get rid of all the decimals. And so when multiplying by 100, we're left with 100 over 225. Now to write this in its simplest form, we can see that 100 and 225 are both multiples of 25, and so we can divide both the numerator and the denominator by 25. And so we end up with the fraction 4 over 9. And so we found that the volume of sphere P as a fraction of the volume of sphere R is equal to 4 over 9, which we can write down in our answer box below. Now there were slightly different ways that we could have approached this question. We used an algebraic approach, but what we could have done is use numbers. We could have said that the volume of sphere P is equal to 100, and knowing that the volume of sphere Q is 50% more than the volume of sphere P, we could have said that the volume of sphere Q would be 100 multiplied by 1.5, which is equal to 150. And then knowing that the volume of sphere R is 50% more than the volume of sphere Q, we could have said that the volume of sphere R would be 1.5 multiplied by 150, which would leave us with 225. And so we could have said that the volume of sphere Q as a fraction of the volume of sphere R would be 100 divided by 225, and then we would have ended up in the same situation as before. We would have started our fraction with 100 over 225, and then we would have simplified and found that the answer is equal to 4 over 9. Now this question is worth 3 marks. We get the first mark by finding the volume of sphere P and sphere Q, and by explicitly showing that the volume of sphere Q is 50% greater than the volume of sphere P. And we did this by saying that the volume of sphere P is equal to V, and the volume of sphere Q is 50% more than this and is equal to 1.5V. And the second mark is for finding that the volume of sphere R would be 50% greater than the volume of sphere Q, and we did this by doing 1.5 multiplied by 1.5V, and for showing that the volume of sphere R would therefore be equal to 2.25V. And we get the third and final mark for finding the volume of sphere P as a fraction of the volume of sphere R, and by doing V divided by 2.25V, and eventually simplifying to find the correct final answer of 4 over 9. And so we've now achieved the full 3 marks needed in this question. In this question, we're asked to prove that n squared minus n is never an odd number, given that n can be any integer, such that n is greater than 1. Well, to prove that n squared minus n is never an odd number, we can use algebra to find n squared minus n when n is odd and when n is even. Let's start by finding n squared minus n when n is an odd number. Now algebraically, we can write an odd number as 2n plus 1 or 2n minus 1. We know that 2n must be an even number because anything multiplied by 2 is even. And so 2n plus 1 or 2n minus 1 is a number before or after an even number, which means that 2n plus 1 or 2n minus 1 is always an odd number. let's say that n is 2n plus 1. And so n squared minus n is equal to 2n plus 1 all squared minus 2n plus 1. And so 2n plus 1 all squared would be equal to 4n squared plus 4n plus 1, and then we have the minus brackets 2n plus 1 at the very end. Now it's important to be careful of our brackets. If we have minus and then brackets 2n plus 1, this becomes minus 2n minus 1. Because looking at our writing in green, we can imagine that minus brackets 2n plus 1 is actually minus 1 multiplied by the whole expression 2n plus 1, and so minus 1 multiplied by the 2n would be minus 2n, and minus 1 multiplied by 1 would be minus 1. So now when we simplify this, we'll get 4n squared, and then 4n minus 2n, which is equal to 2n, and then 1 take away 1, which is equal to 0. And so simplifying this, we're left with 4n squared plus 2n. Now factorising the 2 out, we can say that 4n squared plus 2n is equal to 2 multiplied by 2n squared plus 1. Now since we've been able to factorise the 2 out, we've proven that 4n squared plus 2n is a multiple of 2. And so if it's a multiple of 2, it must be an even number. And so we've now proven that if n is odd, n squared minus n is an even number. Well, now we need to do the same thing, but if n is an even number. Well, algebraically, we can say that an even number is equal to 2n. And so if n is even, n squared minus n is equal to 2n all squared minus 2n. Now simplifying this, 2n all squared is equal to 4n squared, and then minus 2n is 4n squared minus 2n. We can factorise the 2 out, and we can say that 4n squared minus 2n is 2 multiplied by 2n squared minus 1. Like we said before, this expression has been multiplied by 2. If it's a multiple of 2, we know that 4n squared minus 2n is an even number. And so it's important that we have a conclusive statement at the end of our working out, to say that if n is odd, n squared minus n is even, and if n is even, n squared minus n is also even. And so n squared minus n is always an even number. And so we've now proven that n squared minus n is never an odd number. Now this question is worth 2 marks. We get 1 mark for finding the value of n squared minus n when n is odd and when n is even. And then we get the 2nd mark for factorising the expressions that we get. And so when n is odd, when we factorise the 2 out, we find that n squared minus n is 2 multiplied by 2n squared plus 1. And if n is even, when we factorise the 2 out, we'll find that n squared minus n is equal to 2 multiplied by 2n squared minus 1. And so by factorising the 2 out, we were able to prove that n squared minus n is an even number, regardless of whether n is odd or if n is even. And so we've now achieved the full 2 marks needed in this question. In this question, we're asked to find the exact value of tan 30 multiplied by sine 60, giving our answer in its simplest form. Now from our knowledge of standard trig functions, we know that tan 30 is equal to 1 over root 3, and sine 60 is equal to root 3 over 2. And so tan 30 multiplied by sine 60 is 1 over root 3 multiplied by root 3 over 2. Now we can multiply this in the same way we multiply all fractions, by multiplying the numerators together and then multiplying the denominators together. 1 multiplied by root 3 is equal to root 3, and 2 multiplied by root 3 is equal to 2 root 3. And so 1 over root 3 multiplied by root 3 over 2 is equal to root 3 over 2 root 3. Now the root 3's are going to cancel out. And so by essentially dividing both the numerator and the denominator by root 3, we're left with 1 over 2. And so we've now found that the exact value of tan 30 multiplied by sine 60 is equal to 1 over 2, which we can write down in our answer box below. Now this question is worth 2 marks. We get the 1st mark for a process to find 1 over root 3 multiplied by root 3 over 2. And we get the 2nd mark for getting the correct and final answer of 1 over 2, allowing us to get the full 2 marks needed in this question. In this question, we're given a diagram which shows a solid shape. The shape is a cone on top of a hemisphere. We're told that the height of the cone is equal to 10 centimeters. The base of the cone has a diameter of 6 centimeters, and the hemisphere also has a diameter of 6 centimeters. We're told that the total volume of the shape is equal to k pi centimeters cubed, and we need to work out the value of k. We can find the total volume of the shape by finding the volume of the cone, and then finding the volume of the hemisphere and adding these two values together. Let's start by finding the volume of the cone. Now looking at the formula given to us in the top right corner, we're told that the volume of a cone is equal to 1/3 pi r squared multiplied by the height. Well, let's look at the information that we know. Well, we know that the diameter of the cone is equal to 6 centimeters, and so to find the radius, we do the diameter divided by 2, and so we can find that the radius of the cone is equal to 3 centimeters. And now using the fact that the volume of the cone is 1/3 pi r squared h, we can say that 1/3 pi r squared h is equal to 1/3 pi multiplied by 3 squared multiplied by 10, because we know that the height of the cone is 10 centimeters. Well, now let's simplify this. Well, 1/3 pi r squared multiplied by 10 is the same as saying 9 times 10 times pi, all divided by 3, because 3 squared is equal to 9. Then we're left with 90 over 3 pi, which we can simplify and say is equal to 30 pi. And so we've found that the volume of the cone is equal to 30 pi centimeters cubed. Now let's move on to finding the volume of the hemisphere. Well, we know that a hemisphere is half of a sphere. We're told that the volume of a sphere is 4 over 3 pi r cubed. And so we can say that the volume of a hemisphere is this formula divided by 2. And so 4 over 3 pi r cubed divided by 2 would be equal to 4 over 6 pi r cubed. Now let's substitute our values in to this formula. We know that the radius is equal to 3, and so we can say that 4 over 6 pi r cubed is equal to 4 over 6 pi multiplied by 3 cubed. 3 cubed is equal to 27, and so we're left with 4 multiplied by 27 multiplied by pi, all divided by 6, which we can simplify into 108 over 6 pi, which we can say is equal to 18 pi. And so we've found that the volume of the hemisphere is equal to 18 pi. Well, we've found the volume of the cone and the volume of the hemisphere, and so to find the total volume of the shape, we want to add these two values together. And so the total volume would be equal to 30 pi plus 18 pi, which is equal to 48 pi centimeters cubed. We're told that the volume of the shape is equal to k pi centimeters cubed, and so we can now say that k is equal to 48, which we can write down in our answer box. Now this question is worth 4 marks. We get the first mark for an attempt to find the volume of the cone, and for finding that the volume of the cone is equal to 30 pi. We get the second mark for an attempt to find the volume of the hemisphere, and for finding that the volume of the hemisphere is equal to 18 pi. Now we get the third mark for finding the total volume by adding these two values together, and so we found that the total volume would be equal to 30 pi plus 18 pi, which is 48 pi centimeters cubed. And we get the fourth and final mark for finding that k is equal to 48, and for writing this down in our answer box below. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that there are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, or 5. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. In part A, we need to work out the number of different 3-digit numbers that can be set for the combination lock. Well, let's draw a diagram to represent the 3 different digits. We want to think about the numbers that can go in each box. So for digit 1, we could have the numbers 1, 2, 3, 4, or 5, which means that there are 5 possible numbers that can go in the first digit. Now the second digit can also contain any of the numbers 1, 2, 3, 4, or 5, and so the second digit can be one of 5 possible numbers. And now it's the same thing for digit 3. Digit 3 can contain any one of the numbers 1, 2, 3, 4, or 5, and so once again, digit 3 can contain 5 possible digits. And so we can now say that the number of different 3-digit numbers that can be set for the combination lock would be 5 multiplied by 5 multiplied by 5, because there are 5 possible numbers in digit 1, 5 possible numbers in digit 2, and 5 possible numbers in digit 3. And so we've found that the number of 3-digit numbers that can be set for the combination lock is equal to 125. Now in part B, we need to find the number of possible 3-digit numbers that have 3 different digits. This means that none of the digits can be the same. So for example, we can't have something like 5, 5, 3 because there are 2 5s in that combination. All 3 of the digits need to be different. When I look at digit 1, we can say that there are 5 possible numbers that can be in digit 1. We could have 1, 2, 3, 4, or 5. But now let's imagine that we choose digit 1 to be the number 1. We know that the second digit cannot be 1, because all 3 digits need to be different. And so the possible numbers for digit 2 would have to be 2, 3, 4, and 5. Which means that for digit 2, there are only 4 possible numbers. Well, now let's imagine that we choose the number 2 to be the second digit. This means that digit 3 would have to be 3, 4, or 5, because it can't be 1 and it can't be 2. And so we can see that the third digit could only be 3 possible numbers, 3, 4, and 5. And so we can see that the number of possible 3-digit numbers which have 3 different digits would be 5 multiplied by 4 multiplied by 3, because there are 5 possible numbers for digit 1, 4 possible numbers for digit 2, and 3 possible numbers for digit 3. And so we've found that the number of 3-digit numbers with 3 different digits would be equal to 60. Now this question is worth 4 marks. In part A, we get the first mark for doing 5 multiplied by 5 multiplied by 5. And we get the second mark for the correct answer of 125. And in part B, we get the first mark for doing 5 multiplied by 4 multiplied by 3. And we get the second mark for the correct answer of 60. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that the ratio of x squared to 3x plus 5 is equal to 1 to 2, and we need to find the possible values of x. We can write our ratio as a fraction, and so we can say that x squared over 3x plus 5 is equal to 1 over 2. Now to solve for x, we can start by cross-multiplying the fractions. And so when we cross-multiply, we'd get 2 multiplied by x squared is equal to 1 multiplied by 3x plus 5. And so we end up with 2x squared is equal to 3x plus 5. Well, now let's rearrange and write this as a quadratic equation equal to 0. And so we can do this by moving the 3x plus 5 over to the other side. And so we now end up with 2x squared minus 3x minus 5 is equal to 0. Now to solve for x, let's factorise our quadratic equation. And so we end up with 2x minus 5 multiplied by x plus 1 is equal to 0. Now when x plus 1 is equal to 0, we can rearrange for x and find that x is equal to minus 1. And when 2x minus 5 is equal to 0, we can rearrange for x and find that x is equal to 5 over 2. And so we've now found the 2 possible values of x. We said that x could be equal to minus 1 and x is equal to 5 over 2. This question is worth 4 marks. We get the first mark for writing the ratio as a fraction, and for saying that x squared over 3x plus 5 is equal to 1 over 2. We get the second mark for cross-multiplying and rearranging to write this in the form of a quadratic equation equal to 0, and so we said that 2x squared minus 3x minus 5 is equal to 0. We get the third mark for beginning to solve the quadratic equation, and we did this by factorising, and for saying that 2x minus 5 multiplied by x plus 1 is equal to 0. And our fourth and final mark is for using our factorised equation to find that x is equal to minus 1 and x is equal to 5 over 2. Allowing us to get the full 4 marks needed in this question. In part A, we need to express root 3 plus root 12 in the form a root 3, where a is an integer. Well, since 12 can be written as 4 multiplied by 3, the square root of 12 can be written as the square root of 4 multiplied by 3. Well, now using our surd laws, we can simplify this further. The square root of 4 multiplied by 3 can be written as the square root of 4 multiplied by the square root of 3. And so we end up with root 3 plus root 4 multiplied by root 3. We can simplify root 4 because we know that the square root of 4 is equal to 2. And so we're left with root 3 plus 2 root 3. Now root 3 plus 2 root 3 is equal to 3 root 3. And so we've found that root 3 plus root 12 is equal to 3 root 3. And so we've now written this in the form a root 3, where a is an integer equal to 3. Now in part B, we need to express 1 over root 3 all to the power of 7 in the form root b over c, where b and c are integers. Well, we can say that 1 over root 3 all to the power of 7 is equal to 1 to the power of 7 over root 3 to the power of 7. Well, before we continue, let's simplify root 3 to the power of 7. Well, now root 3 to the power of 7 can be written as root 3 to the power of 6 multiplied by root 3 to the power of 1. Now root 3 can be written as 3 to the power of a half, and so root 3 all to the power of 6 can be written as 3 to the power of a half all to the power of 6. And so we're left with 3 to the power of half all to the power of 6 multiplied by root 3 to the power of 1. Well, now 3 to the power of half all to the power of 6 can be simplified and can be written as 3 to the power of 3, and root 3 to the power of 1 is just equal to root 3. So we're left with 3 to the power of 3 multiplied by root 3. Now since 3 to the power of 3 is equal to 27, we can say that this is equal to 27 root 3. And so we've found that root 3 to the power of 7 is equal to 27 root 3. Well, now we can say that 1 to the power of 7 over root 3 to the power of 7 can be written as 1 over 27 root 3, because we know that 1 to the power of 7 is equal to 1, and root 3 to the power of 7 is equal to root 3. But we need to give our answer in the form root b over c, which means the denominator cannot be a surd. Now to get rid of the root 3 in the denominator, we need to rationalise this fraction, and we can do this by multiplying both the numerator and the denominator by root 3. So we have 1 multiplied by root 3, which is equal to root 3. Then we have 27 root 3 multiplied by root 3. Now since root 3 multiplied by root 3 is equal to 3, we can say that 27 root 3 multiplied by root 3 is equal to 27 multiplied by 3. We can simplify this because we know that 27 multiplied by 3 is equal to 81. And so we're left with an answer of root 3 over 81. And so we've now found that 1 over root 3 all to the power of 7, written in the form root b over c, is equal to root 3 over 81, where b is equal to 3 and c is equal to 81. Now this question is worth 5 marks. Now in part A, we get 1 mark for simplifying root 12 and for saying that root 12 is equivalent to 2 root 3. And we get the 2nd mark for getting a final answer of 3 root 3. Now in part B, we get the 1st mark for simplifying root 3 all to the power of 7, and for saying that root 3 to the power of 7 is equal to 27 root 3. Now we get the 2nd mark for having 1 over 27 root 3, and for rationalising the denominator by multiplying both the numerator and the denominator by root 3. And we get the 3rd mark in part B for simplifying and for getting the correct answer of root 3 over 81. And so we've now achieved the full 5 marks needed in this question. In this question, we're told that x squared minus 6x plus 1 is equal to x minus a all squared minus b, and we need to find the value of a and the value of b. Now we're being asked to complete the square. We start off with x squared minus 6x plus 1. Now to complete the square, we're going to start with x. And now we want to halve the number in front of the x term. We have x squared minus 6x plus 1. The number in front of the x term is minus 6, and so half of minus 6 would be equal to minus 3. And so to complete the square, we want to do x minus 3 and then all squared. So if, for example, our quadratic was x squared minus 8x plus 1, we'd do x minus 4 all squared, because minus 8 divided by 2 is equal to 4. Or if we had x squared plus 10x plus 1, we'd do x plus 5 all squared, because 10 divided by 2 is equal to 5. Now we have x minus 3 all squared. So looking at the term over here, we have the number 3. We want to take away 3 squared. And so we'll say minus 3 squared. And we don't want to forget about our plus 1 at the end. So we add 1 at the end. Now we can simplify this. We know that 3 squared is equal to 9. And so x minus 3 all squared minus 3 squared plus 1 is equivalent to x minus 3 all squared minus 9 plus 1. Minus 9 plus 1 is equal to minus 8. And so this is now equal to x minus 3 all squared minus 8. And so we can see that we've now written this in the form x minus a all squared minus b. And so we can see that the value of a is equal to 3 and the value of b is equal to 8. Now in the second part of this question, we're asked to write down the coordinates of the turning point of the graph of y equals x squared minus 6x plus 1. We said that y equals x squared minus 6x plus 1 can be written as y equals x minus 3 all squared minus 8. Now when we complete the square, we have a general rule for finding the turning points. And this rule is that if y is equal to x plus a all squared plus b, the turning point is equal to minus a, b. So the x coordinate of the turning point would be the opposite of what's inside the bracket. For example, if we had minus 4 in the brackets, the x coordinate of the turning point would be plus 4. But if we had plus 8 in the brackets, the x coordinate of the turning point would be minus 8. And b just stays the same. If b is equal to 5, the y coordinate of the turning point is equal to 5. Or if b is equal to minus 7, the y coordinate of the turning point is equal to minus 7. Well, our equation is equal to x minus 3 all squared minus 8. The number in the brackets is equal to minus 3, and so the x coordinate of the turning point would have the opposite sign. And so instead of minus 3, the x coordinate of the turning point would be equal to positive 3. And then we have minus 8, and so the y coordinate of the turning point would just be equal to minus 8. And so we can see that the turning point of the graph of y equals x squared minus 6x plus 1 is equal to 3 minus 8. Now this question is worth 3 marks. We get the first mark in the first part of the question for a process to start completing the square. And we get the second mark for correctly finding that a is equal to 3 and b is equal to 8. In the second part of the question, we get the 1 mark for getting the correct turning point of 3 minus 8. And so we've now achieved the full 3 marks needed in this question. In this question, we're told that h is inversely proportional to p, and then we're told that p is directly proportional to root t. Given that h is equal to 10 and t is equal to 144 when p is equal to 6, we need to find a formula for h in terms of t. Now let's start by setting up equations that represent our proportionalities. Now if h is inversely proportional to p, we can say that h is equal to some constant over p, and we can call this constant any letter. So let's say that constant is a. We can say that h is equal to a over p. Then we're told that p is directly proportional to the square root of t. Now if it's directly proportional, we can say that p is equal to some constant multiplied by root t. And now be careful not to use the same constant for our formula for h and our formula for p, because these two constants are not necessarily the same. So we can say that p is equal to b root t, where our constant is equal to b. Now we want to find these two constants so that we have a formula for h and a formula for p. We'll start by finding the formula for h. Now we're told that h is equal to 10 and t is equal to 144 when p is equal to 6. And so we can substitute these values into our formula for h. We know that h is equal to a over p. We can see that we don't need the value of t for this part. We're trying to find a, and we know the value of h and p. H is equal to a over p, and so 10 is equal to a over 6. Because we know that h is equal to 10, when p is equal to 6. And multiplying both sides by 6, we can say that a is equal to 10 multiplied by 6, which is equal to 60. And so we've found that h is equal to 60 over p. Now we need to find the formula for p. We said that p is equal to b multiplied by root t. We know that p is equal to 6 when t is equal to 144, and we need to find b. And so we can say that 6 is equal to b multiplied by the square root of 144. Simplifying this, we know that the square root of 144 is equal to 12, and so 6 is equal to b multiplied by 12. And now dividing both sides by 12, we can say that b is equal to 6 divided by 12, which is equal to 1 over 2. And so given that p is equal to b root t, and we now know that b is equal to 1 over 2, we can say that p is equal to 1 over 2 multiplied by root t. And writing this in a slightly different way, we can say that p is equal to root t over 2. And so we found that h is equal to 60 over p, and p is equal to root t over 2. We're asked to find the formula for h in terms of t. And so knowing that p is equal to root t over 2, we can substitute this in to our formula for h. So let's write down the fact that h equals 60 over p. Now if we know that p is equal to root t over 2, we can say that h is equal to 60 divided by root t over 2. Now let's write this in a way that's easy for us to work out. H equals 60 divided by root t over 2. Now when we divide by a fraction, we can flip the fraction and change the division sign into a multiplication sign. And so we can say that h is equal to 60 multiplied by 2 over root t. And so when we multiply this fraction, we'll find that h is equal to 120 over root t. And so we've now found a formula for h in terms of t. And so our answer to this question is that h is equal to 120 over root t. Now this question is worth 4 marks. We get the first mark for setting up our equations, and for saying that h is equal to a over p, and p is equal to b root t. We get the second mark for substituting the values given to us to find a formula for h and a formula for p. Now we get the third mark for finding that h is equal to 60 over p, and for finding that p is equal to root t over 2. And finally, we get the fourth mark for substituting our formula for p into our formula for h, and for getting a final answer that h is equal to 120 over root t. And so we've now achieved the full 4 marks needed in this question. In this question, we're told that the functions f and g are such that f of x is equal to 3x minus 1, and g of x is equal to x squared plus 4. And in part A, we need to find the inverse function of f of x. We know that f of x is equal to 3x minus 1, and so we can write this as y equals 3x minus 1. And now to find the inverse function of f of x, we can rearrange and make x the subject. And so we can start by bringing the minus 1 over to the other side. And so we can say that y plus 1 is equal to 3x. Now we want to divide both sides by 3. And so we can say that y plus 1 all divided by 3 is equal to x. We've now made x the subject of our expression and found that x is equal to y plus 1 over 3. And now to write this in the correct form, we can say that the inverse function of f of x is equal to x plus 1 over 3, which we can write down in our answer box. Now in part B, we're told that f of g of x is equal to 2 multiplied by g of f of x, and we need to find that 15x squared minus 12x minus 1 is equal to 0. Well, we know that f of x is equal to 3x minus 1, and g of x is equal to x squared plus 4. Well, let's start by finding f of g of x. Now we can write this in a way that's slightly easier to understand. And so to find f of g of x, well, knowing that f of x is equal to 3x minus 1 and g of x is equal to x squared plus 4, we can say that f of g of x is equal to f x squared plus 4. And so we can say that f of x squared plus 4 is equal to 3 multiplied by x squared plus 4 minus 1. Now let's expand these brackets. 3 multiplied by x squared plus 4 is equal to 3x squared plus 12. And so f of x squared plus 4 is equal to 3x squared plus 12 minus 1, which we can simplify and say is equal to 3x squared plus 11. And so we've now found that f of g of x is equal to 3x squared plus 11. Next we need to find g of f of x. And again, we can write this in a way that's slightly easier for us to understand. And now to find g of f of x, well, knowing that g of x is equal to x squared plus 4 and f of x is equal to 3x minus 1, g of f of x would be equal to g of 3x minus 1. And now to find g of 3x minus 1, we'd do 3x minus 1 all squared plus 4. Now let's expand these double brackets. 3x minus 1 all squared is equal to 9x squared minus 6x plus 1. And so g of 3x minus 1 would be equal to 9x squared minus 6x plus 1 plus 4. And so simplifying this by adding the 4 at the end, we can say that g of 3x minus 1 is equal to 9x squared minus 6x plus 5. And so we've now found that g of f of x is equal to 9x squared minus 6x plus 5. Well, now we're told that f of g of x is equal to 2 multiplied by g of f of x. We know that f of g of x is equal to 3x squared plus 11, and g of f of x is 9x squared minus 6x plus 5. And so if f of g of x is equal to 2 multiplied by g of f of x, we can say that 3x squared plus 11 is equal to 2 multiplied by 9x squared minus 6x plus 5. Well, now let's expand the right hand side by multiplying each term by 2. And so we can say that 3x squared plus 11 is equal to 18x squared minus 12x plus 10. Well, now let's rearrange by bringing the 3x squared plus 11 over to the other side. And so we're left with 0 equals 15x squared minus 12x minus 1. And so we've now shown that 15x squared minus 12x minus 1 is equal to 0. Now this question is worth 7 marks. In part A, we get the first mark for the first step to change the subject, and for saying that y is equal to 3x minus 1. And we get the second mark in part A for rearranging to find x, and for finding that the inverse function of f of x is equal to x plus 1 over 3. Now in part B, we get the first mark for finding that f of g of x is equal to 3x squared plus 11. We get the second mark for finding that g of f of x is equal to 3x minus 1 all squared plus 4. And we get the third mark for expanding and simplifying and finding that g of f of x is equal to 9x squared minus 6x plus 5. We get the fourth mark in part B for setting up the equation 3x squared plus 11 is equal to 2 multiplied by 9x squared minus 6x plus 5. And we get the fifth and final mark in part B for rearranging to prove that 15x squared minus 12x minus 1 is equal to 0. And so we've now achieved the full 7 marks needed in this question. In this question, we're told that there are only R red counters and G green counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 3 out of 7. The counter is then put back in the bag. We're then told that 2 more red counters and 3 more green counters are put in the bag, and a counter is taken at random from the bag again. Now the probability that the counter is green this time is 6 over 13. and we need to find the number of red counters and the number of green counters in the bag originally. Now let's draw a table to help us visualize this. So in this table, we have the original probability of picking a green counter, the original probability of picking a red counter, the probability of picking a green counter after more counters were added, and the probability of picking a red counter after more counters were added. Well, now we're told that originally the probability that the counter is green is 3 out of 7. And so we can say that this probability is equal to 3x over 7x, because 3 out of 7 may be a simplified fraction. And so including the 3x over 7x helps us to find how many green counters there were in the bag. Now if the probability of picking a green counter is 3x out of 7x, the probability of picking a red counter would be 7x minus 3x out of 7x, and so the probability of picking a red counter originally is 4x out of 7x. Now we need to see the probability of picking a green counter after more counters were added. We're told that 2 more red counters and 3 more green counters are put in the bag, and so the total number of counters would be 7x plus 2 plus 3, which is equal to 7x plus 5. If 3 more green counters are added, then the probability of picking a green counter after the more counters are added would be equal to 3x plus 3 over 7x plus 5. And likewise, we're told that 2 more red counters are added, and so the probability of picking a red counter after more counters are added would be 4x plus 2 over 7x plus 5. Now looking back at the information in the question, we're also told that the probability that the counter is green after more counters are added is 6 over 13. Now looking at our table, the probability that the counter is green after more counters are added is 3x plus 3 over 7x plus 5. And so we can say that 3x plus 3 over 7x plus 5 is equal to 6 out of 13. Now we need to cross multiply. We can say that 13 multiplied by 3x plus 3 is equal to 6 multiplied by 7x plus 5. Now expanding these brackets, we can say that 39x plus 39 is equal to 42x plus 30. Now let's move the 39x over to the other side, and we're left with 39 is equal to 3x plus 30. Now taking 30 away from each side, we can say that 9 is equal to 3x. And so we can conclude that x is equal to 3. Now let's remind ourselves about what the question is actually asking us. We need to find the number of red counters and the number of green counters that were in the bag originally. Now looking at our table, the number of green counters originally in the bag would be 3x, and the number of red counters originally in the bag would be 4x. Now we found that x is equal to 3. And so let's start with the number of red counters. The number of red counters would be equal to 4x, which would be equal to 4 multiplied by 3, which is equal to 12. And then the number of green counters would be equal to 3x, which is 3 multiplied by 3, which is equal to 9. And so we've now found that the number of red counters that were initially in the bag is equal to 12, and the number of green counters initially in the bag is equal to 9. Now this question is worth 5 marks. We get the first mark for identifying that the number of green counters after more counters are added is equal to 3x plus 3 over 7x plus 5, and for identifying that the number of red counters after more counters are added is equal to 4x plus 2 over 7x plus 5. We get the second mark for saying that 3x plus 3 over 7x plus 5 is equal to 6 over 13. Then we get the third mark for cross multiplying and for finding that 39x plus 39 is equal to 42x plus 30. We then get the fourth mark for correctly solving and for finding that x is equal to 3. And finally, we get the fifth mark for substituting our value of x back into our original equations to find that the original number of red counters in the bag is equal to 4x, which is equal to 12, and the original number of green counters in the bag is equal to 3x, which is equal to 9. And so we've now achieved the full 5 marks needed in this question.